Okay, all right. Hello, my name is Larry Touchette. I'm a solution architect with NetApp. I work in a Flash Solutions group. I'm going to spend a few minutes just talking to you about Flash and hybrid storage and some considerations you should make when considering these technologies. So it'll just take a few minutes and we'll move through things pretty quick. So I did want to start by kind of level setting and make sure we're all talking about things in the same context. So we know that hard drives traditional media hard drives have increased in capacity much quicker than what they've increased in their ability to deliver performance. So what that essentially means is that you may require as much capacity as what I'm showing here on the left in the black dot, but in order to meet your performance requirements, you have to provision enough hard drives so that you have enough spindles to keep your performance at a decent level. And so there's this large amount of over-provisioning in a lot of environments today. If you combine flash storage with your traditional media hard drives, what this does is it changes the flash acceleration profile of your entire storage solution. So it pushes that line over to the left, and then you can provision the amount of capacity much closer to what your performance requirements are. And in those cases where you really need a lot of extreme performance, even at much lower capacities, this is where all-flash arrays would tend to fit into your solution considerations. Now, if you look at all of the solutions across the broad spectrum of storage capabilities, there's hard drive-only solutions way on the right-hand side. Those are going to give you the lowest cost per gigabyte, but the highest cost per IOP. There's hybrid storage solutions in the center. And within that, there's two different kinds. There are server cache solutions where the cache exists inside the server, and then there are solutions where there is cache technology used in the array combined with spinning media. So most of your workloads are going to fit within this hybrid solution case. In the hybrid storage solutions, you have to keep in mind that these are composed of two different types of media, very fast flash and slow spinning disks. So you get low latencies for reads that come from the cache or writes that might go into a write-back cache, and you get high latencies for IOPS that have to come from spinning disk. What this means is your application performance is going to be dependent on an average of these, and that's what I'm going to talk to across a few of the next slides. And then all the way on the left is all-flash arrays, and the key thing to keep in mind with all-flash arrays is that they always deliver that consistent low sub-millisecond latency. So if your goals are capacity-oriented, you'll be closer to the right-hand side of this. If your goals are performance-oriented, you'll be mid to closer to the left-hand side of this, this kind of paradigm of different medias that we have. So to understand what these technologies really mean, again, considering your goals, if your goals are performance improvement, then that means you need lower latency. You want to reduce the amount of clock time it takes for specific action to occur within your infrastructure. Your goals might be efficiency-oriented, meaning you've got enough IOPS in your system and you've got enough good performance, but maybe you want to add more workloads, and this essentially means you need more IOPS, so you can do that with flash as well. Now the interesting stuff starts to happen here, where if you consider the latency that you get from each type of media in a storage stack, so let's say for a cache that exists in the server, I might get 1/10 of a millisecond of a response time when I get a cache hit. If I put a cache in a storage array, there's a bit of a network hop there, so I might get a 4/10 of a millisecond access to that. In terms of user experience, those are very close, almost indiscernible. But then if you compare both of those to the latency capabilities in traditional storage media, there's up to a 300x performance difference there. So you have to keep in mind again that your application performance is going to be dependent not on the speed of your cache hits or the speed of your cache misses, but on the average latency between those two. And this is something really easy to figure out. So if you know your cache hit rate, which any hybrid storage solution is going to tell you how often IOPS come from cache versus from your spinning disk, you can take your cache hit rate times your cache latency and add that to your miss rate times your disk latency, and that gives you an average latency. So a really easy example here is if I'm getting 50% of my IOPS at 1 millisecond, and I'm getting the other half of my IOPS at 10 milliseconds, then I have a 5.5 millisecond average latency. So my storage stack and my applications will behave as though 5.5 milliseconds is what my solution's capable of delivering. And we can look at a couple examples of this to put this like in a better context. So if I have a workload on a storage array that's capable of giving 10 milliseconds, and I put in enough cache to get 60% of my IOPS to come from the cache, then I would have a 4.24 millisecond average latency. But if I deploy a server cache solution where the cache characteristics are exactly the same and I use the same amount of cache, so I'm getting the same cache hit rate, then my average latency is going to be 4.06 milliseconds. So there's not much of a difference here. You're not having really a performance difference between these two. But there are still some differences that you need to consider in which technology you'd want to use. So if we look at an infrastructure with maybe a few mixed workloads, cache in the storage array, that's going to offload IOPS from your spinning media into flash in the storage array. So it's going to make your spindles more efficient. Cache in the server is going to offload IOPS all the way up the stack into the server. So not only do the IOPS not have to be serviced by the disks in the array, but they don't have to be serviced by the array at all. So there's a different layer where the efficiency effect occurs. And then you also have to consider that just about every hybrid storage solution out there, the cache in the storage is going to accelerate multiple workloads, or it's probably less granular in the workloads that you can assign the cache to. And then if you put cache in the server is, you can target that at specific hosts or at specific virtual machines. So this is a way to target flash capacity at a specific application. So you can dedicate the cache to that application and get the performance improvement to occur exactly where you want it. So these are some things to consider kind of operationally in the difference between these caching technologies and when you should use one or the other. It's not just about the performance they deliver, but also about the effect that they have in the environment. And the last thing I wanted to talk about was to kind of put these hybrid storage solutions in context of thinking about them in terms of where do all-flash arrays fit into this. So in this slide, this is really just a mathematical model of where average latencies would come out. So the latency is shown on the left there, 0 at the bottom and 10 at the top, and then different cache hit rates along the bottom. So as the cache hit rate gets higher, the average latency will come down. And if you notice, there's two lines here on this graph. So the green line is where the average latency would be if my cache ops, my cache hits were coming at around 400 microseconds. The orange line is where my average latency would be if my cache hits were coming at just 100 microseconds. So there's not much difference discernible in user experience or what a user might experience in their applications anywhere along this line until you get way out to the right-hand side where you've got a very high cache hit rate, but then you're still under a millisecond for both of those. So this average latency phenomenon occurs in any hybrid storage solution, and for most workloads, you're going to want to be at the 5 to 3 millisecond range, or maybe up to the 7 millisecond range with cache hit rates around 50 to 70%. Those types of solutions are going to work for almost any workload. Now, where this is differentiated from an all-flash array is, what if you didn't want this average latency phenomenon to occur? What if every IOP all the time needed to be very fast? Well, this is what an all-flash array would look like if it was on this chart. If flash arrays are typically capable of delivering sub-millisecond latency, there's no average latency phenomenon. Every IOP reads and writes are all, there's no cache, but you could essentially call them flash hits. So this is a good way to think about the differences between hybrid storage solutions using flash in the array and hybrid storage solutions using flash in the server, and then also a little bit about where all flash arrays kind of fit in the mix. And that's all I had. Again, my name is Larry Touchette. I'm with NetApp, so thanks for listening.